Okay, so we're going to do another practice sampling distribution problem with probability, but not with probability, but with means instead of proportions. So we're doing a means problem. And in this problem, we're going to still follow the same 5 steps. We are told that adult female heights in the US are roughly normally distributed with a mean height of 64, so that's mu, my parameter for the population, and a standard deviation of 3 inches. So again, write down what we have. We're skipping this first part. We're coming now. Suppose we plan to take a random sample of 10 females. We want to check the conditions, describe the distribution, and then we're going to see what is the probability that their mean height is greater than 67 inches. So step 1, identify our parameter. The parameter is mu, which is the true mean height for all US females, and that's 64 inches. Second thing is our conditions. Do we have a simple random sample? Yes, it's stated, quote, random sample of 10. The 10% condition, it is reasonable to assume that the 10 females we chose is less than 1/10 of all the US adult females. Finally, for approximately normal, remember, if we're dealing with means, there are 2 ways to show that it's approximately normal. One is that the population is normal. The second way is if our sample size is greater than 30. My sample size was 10, so that can't be the method or the reason. However, I was given that the population is roughly normally distributed. So I'm given the population is roughly normal. So thus the sampling distribution is approximately normal. So I've met my 3 conditions. Now we need to look at and describe the distribution, the sampling distribution of X bar. And again, X bar means the mean taken from a sample. The shape is approximately normal because the population was normal. And again, I sort of drew that arrow to sort of show, I don't need to write it twice, but just show that I did do the calculations, are the reason. The center, mu sub X bar, so the center of a sampling distribution of means, is equal to the center of the population, which in this case was 64 inches. The spread, so the standard deviation of X bar is equal to the standard deviation of your population divided by the square root of n, your sample size. Put in our numbers, and here's my standard deviation. Again, notice I'm keeping 4 decimal places. Okay, so now we want to do the probability portion. So step 4 is our Z calculations. I am looking for what is the probability that the mean height, that's X bar, is greater than 67 inches. So this is what I'm looking for. I label it as normal, my mean and standard deviation, draw my normal curve, putting in the mean value and the value I'm looking for. I'm looking for 67 or greater, so I shade to the right. And this, everything on the x-axis represents the mean value from a sample, so X bar. And since I've shaded to the right, I know that whatever probability I find, I'm going to have to subtract from 1. So I want to show my definition of Z, which is observed minus the mean divided by standard deviation, or I can use the specific ones for a sampling distribution of X bar. So X bar minus mu divided by standard deviation divided by square root of n. Put in the actual values here, and we get our Z-score of 3.16. From the table, I get a probability of 0.9992. So the probability of X bar being greater than 67 is equal to 1 minus that, which is 0.0008. And finally, we want to wrap up with an interpretation. Given the true mean height for all US female adults is 64 inches, the probability of taking a random sample of 10 and getting a mean height greater than 67 inches is 0.0008. Or in other words, very, very unlikely. Okay, so I've got a second one for you to practice on, and we'll go over that in class. And this is a rabbit problem. So again, you want to skip part A, because that's not really what we're looking at. But we want to have a particular breed of rabbits that the mean weight is 5, the standard deviation is 4, and the distribution for these rabbits is skewed to the right. So it's important that you note that. And here's what we're looking for. That a random sample of 35 rabbits have a mean weight less than 7 pounds. Okay, so that's what you're trying to calculate. What is the probability of your X bar being less than 7? And we will go over that in class tomorrow.